All right. Algebra 1, folks. Thank you for hopping into lesson 37. You've made it. Lessons 1 through 36 in the books. We are on to 37. 37 is all about polynomials, adding and subtracting polynomials. I promise you, if you can add and subtract, then you can add and subtract polynomials, okay? Let's start with this. Keep it basic. Keep it simple. Keep it simple, stupid. All right, what can we do by the end of this lesson? I can add and subtract polynomials. Okay, little quick piece of information for you before we start adding and subtracting them. We need to know what the heck is a polynomial, okay? A polynomial is just a combination of numbers and variables, okay, combined through either multiplication, addition, or subtraction. So 3 of the main types of polynomials, okay, it's a word you're going to want to get used to. 3 of the main types of polynomials that you see are monomials, okay, which would just be mono means one. If you think about like the expression mono e mono, it's like 1 versus 1. Monomial is just one term. This whole thing is one term. This is one term. This is one term. Those are 3 examples of monomials, okay? The second one you're going to see is binomials, right? Bi means 2, right? Like bivariate data, 2 pieces, or like bicycle, 2 tires, right? Okay, which would be 2 terms. So here's an example of something that has 2 terms. There's term 1, term 2. Here's another example. So is that. All 3 of those are example of binomials. Okay, the third one you see a lot of is trinomials. You guessed it. Tri stands for 3. Think about triangle, 3 sides. Tricycle, 3 tires. Okay, so trinomials are just 3 something is a polynomial that has 3 terms, right? That has 3 terms. Term 1, term 2, term 3. So does this one. So does this one. Term 1, term 2, term 3. They're separated by plus or minus signs. Okay, what we want to be able to do today is add and subtract some of these polynomials. And like I said, if you can add and subtract, then you can add and subtract polynomials. Okay, all right, get off here. Come on now. Come on now. There we go. Okay, so what we need to do, we're going to look at this first example, and I'm going to show you what I mean by this being as easy as it sounds. We have this example. We're taking this binomial. It's in parentheses, okay? It's a binomial because it has 2 terms, term 1 and term 2. And we are adding it to, why do I know it's adding? There's a plus sign. And I'm adding it to this binomial. I'm saying binomial again because this piece has also 2 terms. I can tell it's being held in there by parentheses. I'm essentially just combining like terms from polynomial 1. I'm going to call this polynomial 1 to polynomial 2. Well, what's alike? I see 4x. And I see 3x. Those are like terms. You've learned that. You learned that in middle school, what like terms were. I'm going to combine them, and it says to add 4x plus 3x is 7x. I'm done with this. I'm done with this. Okay, I see a negative 5, and I see an addition sign still being added to 6. Well, what's negative 5 plus 6? My brain and my calculator tells me that it is plus 1, a positive 1. That is my final answer. Why can't I do 7x plus 1? They're not like terms. So my new answer as a binomial, because there's 2 terms still, is 7x plus 1 is my final answer. Very straightforward, okay? All right, we're going to look right here at example number 2. Example number 2, we need to pay attention to, do they have the same variable, and do those variables have the same exponent, okay? So what I'm seeing here, I'm going to look at my first binomial again. Okay, I see x to the second power plus y to the second power. That's my first binomial. I see this time I'm subtracting. How do I know that? There's a minus sign. I'm not being tricky. I'm not like, where is it? Is it adding or subtracting? It's right there. Okay, it's telling me to subtract. What's it telling me to subtract? It's telling me to subtract this second binomial, 4x squared plus 3y squared. Okay, so I'm looking for like terms. This is an x squared and so is this. Okay, that means I need to subtract those. This says 1x squared. I say 1 because there's no number in front. That means there's just one of them. 1x squared minus 4x squared. Think about what is 1 minus 4? It's negative 3. What did they have in common? They were x squared terms. I need to leave it that way. Okay. I'm taking essentially how many x squareds do I have first? How many x squareds do I have second? It was 1 minus 4. 1 minus 4 is negative 3. And what made them like terms? They were both x squared. So I'm essentially done with this and this. I'm looking at my next term. I see y squared. Again, it's just one of them, right? That's a 1. It's a junky looking 1. 1y squared minus, again, there's a minus sign. I'm going to emphasize this. 1y squared minus 3y squared. Well, think about your coefficients. 1 minus 3 is negative 2. What did they have in common? They still have that thing in common. It was a y squared. Why can't I take this any further? Because x squared and y squared are not alike. So my answer is a binomial. I would read it as negative 3x squared minus 3y squared. Okay. Let's dive into a bigger example. Okay, so now we're not looking at binomials. We're here on example number 3. We're looking at trinomials. I say trinomial because look how many terms. Term 1, term 2, term 3. Okay, what is it doing? It's asking us to add them. It's saying, hey, take this piece and add it to this piece. When I say piece, I'm talking about these polynomials, specifically trinomials. Okay, so I'm just going to start from left to right. This is 3x squared. Are there any x squareds over here? There are. Negative 3x squared. So now I'm just looking at the coefficients. 3 plus negative 3 is 0. I don't have any x squareds left. I just lost them all. I do not need to write 0x squared. I don't write that. They're gone. All of my x squareds are gone. Imagine you're a car salesman. There's 3 cars in the lot. If I have 3 cars and I subtract 3 cars, my answer isn't C or 0C, right? There's no cars left. There's nothing. There's nothing to show for it, right? So 3x squared and negative 3x squared are gone. My next term I'm looking at here is a negative 5xy squared, and I see another term that has xy squared. So these are alike. It's not the 5 that makes them alike. It's their variables and exponents. They both have xy squared, xy squared. Negative 5 plus negative 5 is negative 10xy squared. I leave the variables and the exponent alone. That's what made them similar. I leave them that way. Done. Done. My last thing, y to the third, and that's one of them, and negative 1y to the third. Those are alike because they both have a y raised to the power of 3. If one of them was y squared and the other one was y to the third, they wouldn't be alike. But these are alike. So 1y to the third plus negative 1y to the third. We get a situation like these x's from before. 1 plus negative 1 is 0. These are gone. My answer is a monomial. That's one term. There's no addition or subtraction signs left. It says negative 10xy squared. My answer is a monomial. There's just one piece. All right. Let's look at this next one. I see subtraction here. Again, how do I know it's subtraction? Boom, there's a subtraction sign right there. So I see 6x squared. I'm looking at my first term. And I see 2x squared. I'm looking at my second term. They both are x squareds. So it's essentially saying, hey, dude, do 6 minus 2. You guys learned how to do that. I learned how to do that. Felt like when I learned how to walk, right? Long time ago. 6 minus 2 is 4. What do they have in common? X squareds. Done. Done. Next piece, 12xy and negative 8xy. And I'm subtracting 12 minus negative 8 is a positive 20. I need a plus sign for positive. Positive 20xy. It's saying, hey, I have 20xy's. Imagine you're holding 12xy's in your hand, and then you subtract negative 8xy's in your other hand. You would have 20xy's left. Done. Done. Last piece, y squared. 4y squared and 2y squared. They're both positive. It's saying do 4 minus 2. That's a positive 2y squared. My answer is a trinomial. Trinomial because it has 1, 2, 3 pieces that are separated by plus or minus signs. I can't combine any of these 3 pieces because this is an x squared, this is a y squared, and this is an xy. All 3 of those are unique. Okay, hopping down below. Sometimes you're going to be given some polygons, some shapes, and it's going to say, hey, tell me something, right? Okay, well, here's what we know. Look at example number 5. It says P equals 5x plus 2y. We know the perimeter of this whole thing, this side plus this side plus this side, is 5x plus 2y. Well, I know I have some x's here and here, but we're missing a piece. I need to know what polynomial is over here, right? Think about this, right? I know the whole entire sum is 5x plus 2y. This is what I'm thinking. I'm going to stack these. I'm going to take this first one, and I'm going to write 2x minus 3y. And I'm going to take this second one, which is this one, x plus 2y. And I'm going to leave a space. I know something should go right here, but when I add them all up, I should get this answer. 5x plus 2y. Okay, so what is this other polygon? Well, think about this. 2 plus 1 plus what is 5? 2 plus 1 is 3. 3 plus what is 5? This should be a 2x. Okay, my first missing piece is 2x. This is 2x something, right? Because 2 plus 1 is 5. I know I'm good there. Then I have negative 3 plus 2 plus something equals 2. A little bit more work. Negative 3 plus 2 is negative 1. Negative 1 plus what number is 2? Okay. I know that that's a positive 3y, okay, plus 3y. How can I tell if I'm right? Add this all up and make sure that you get that perimeter. 2 plus 1 is 5x, and 3 minus 3 is 0, plus 2 is 2. So our missing side, polynomial or binomial answer is 2x plus 3y. Okay, here we know, example number 6, perimeter is 14x squared plus 10x plus 12. I wish there was more of a space here. This is kind of a separate piece of information. This is not the side length here. That's what we're figuring out, question mark, boom, okay? If this looks like a rectangle, like I think it is, okay, we know this side is the same as this side. So that means I know this is 3x squared plus 5. And then we need to figure out what is this, like what's left over. Okay, so think about the whole entire perimeter is 14x squared for this first term. We have 3 plus 3 is 6. So I've used up 6 of 14. I have 14, and I need to take away 6. That leaves me 8. But 8 is to cover two sides. It covers this side and this side. So what does that mean? Well, half of 8 is 4. So that means this side, this question mark, must be 4x squared is the first term. All right, now let's think about this. Here's 10x. Okay, these say nothing about x. There's x squared. There's nothing about x. So I know that there's 10x, and I need to split it over the total of two sides, this side and this side. Well, what's half of 10x? It's 5x. So I know my next term is a positive 5x. Last but not least, I have this 12, just this constant of 12. We've used how much of it? 5 and 5, which is 10. Well, 12 minus 10 is 2, and that's dispersed over these two unknown sides, this one and this one. Well, what's half of 2? Half of 2 is 1. It's positive, so positive 1. How could I check that? I could add this plus this again, because it's this other side that I don't have room to write on, plus this, and I should get this perimeter of 14x squared plus 10x plus 12, and I do. Okay, moving along. So these are just some application problems, right? How can I use this? How and why? If I get $1 every time I said, when am I going to use this? I don't need this, right? You do. You use it. You're going to use it next year. You're going to use it the year after that. You're probably going to use it the year after that. If you go to college, you're going to use it the year after that, the year after that, the year after that, the year after that. If you go to more than 4 years of college, you're going to use it the year after that. If you have any kind of job that involves any kind of math or computation or any kind of real-world application, you're going to use it then and after that, okay? Let's look at problem number 7. 7. The sides of a triangle. Wait, I don't see a triangle. Draw one. Doesn't say what kind of triangle it is. I'm just drawing one. They have lengths of x plus 5, x minus 2, and 2x minus 4. Find the perimeter, okay? Well, it doesn't really tell us which one goes where. I'm going to say this one is x plus 5. I've used that. This one is x minus 2. Whoops, x minus 2. Let's redo that. X minus 2. And this one, we'll call it, since it looks long, as 2x minus 4. We've used that. It says find the perimeter. The perimeter is the distance around the outside here, here, and here. What does that mean I need to do with these? I need to add them up. Find like terms. Here's a binomial, binomial, binomial. This has 1x. This has 1x. This has 2x's. It's as simple as 1 plus 2. That tells me 4x. Done, done, done. These last ones are constants. 5 minus 2 minus 4, or 5 plus negative 2 plus negative 4. I like going straight to the subtraction if I'm working with negatives. 5 minus 2 is 3. 3 minus 4 is negative 1. I cannot combine these two terms because they're not like terms. One has x's, one doesn't. My final answer, the perimeter, is 4x minus 1. Good work, everybody. All right, 2 more. Find the perimeter of a pentagon that has 3 sides of length 2x plus 3 and 2 side lengths of x plus 1. Pentagon, how many sides does it have? Come on, you know this. Well, look, 3 sides and 2 sides. That makes 5 sides. It has 5 sides. 1, 2, 3, 4, 5. What a beautiful polygon. Just take a second, step back, and look at how beautiful that polygon is. Beautiful, right? Okay. It's telling me 3 sides have the same length of 2x plus 3, 2x plus 3, 2x plus 3. It's not nitpicky on where they go. If it was, it would tell you. So you can kind of put these wherever you want, x minus 1 and x minus 1. I need the perimeter again. The perimeter scoots along this side to this side to this side to this side all the way here. Add them all up. 2x plus 2x is 4x, plus another 2x is 6x, plus another x is 7x, plus another x is 8x. When I add all my x terms up, I have 8 of them total. Let's add our constants. 3 plus 3 is 6, plus 3 is 9, minus 1 is 8, minus 1 is 7, a positive 7. My perimeter is 8x plus 7. I do not combine those for the same reason I've told you on the last 7 problems why we don't combine them. They're not like terms. Ooh, look at this one. Okay, we're going to end with an area problem. Area. Okay. It is telling us one rectangle, I'm going to draw it because I like to see my rectangles that I'm visualizing, has an area of 7x squared minus 4x plus 12. And another rectangle has an area of 4x squared plus 2x minus 1. How many more square feet is the first rectangle? So it's asking basically what's the difference? How much bigger is this one than this one? Well, let's figure it out. When I find the difference, when I find out how much bigger something is, think about if I measure your height from mine and I say, how much taller am I than you? You don't add our heights, you subtract them. We need to subtract these two. I'm taking this trinomial and I'm subtracting this trinomial. So let's start doing it. Here's an x squared term. Oh, there's an x squared term. 7x squared minus 4x squared. 7 minus 4 is 3. What made them alike? They both have x squareds. Done. Done. Next one, negative 4x minus 2x. Negative 4 minus 2 is negative 6. What made them similar? They both had x's. They still have an x. It still has an x. Done. Done. 12 minus negative 1. Minus a negative is like adding. Subtracting a negative is like positive. 12 plus 1 or 12 minus negative 1 is 13. How much bigger is one than the other? It is 3x squared minus 6x plus 13 bigger. What does that mean to us? Not much, but can we find it out? Yes. Is that cool? Absolutely. That is your last piece of information on lesson 37. This is probably how your face looks. It's exactly how mine looks, right? Maybe a little even tongue out, like, whoa, check that out, right? I can now add, what do we say we could do? Go back to the top here. We can now add and subtract polynomials. You can even do more than that. You can apply it to solve a real world problems such as these. For the next time someone comes up to you and says, hey, dude, I need to know the perimeter of this triangle. It has 3 sides that are binomials. Tell me the final answer. You know how to do it. Thank you for hopping in. See you in lesson 38 next week.